Okay, so now we're going to move this on to differentiation from first principles when we have a quadratic equation. So we have 2x squared minus 3x minus 7, okay? And we're going to differentiate this now from first principles. We're going to go through the same idea as what we did before, which is basically we're going to develop the given function so that we can substitute it into the formula. This is the first principles formula. Okay, so clearly we start off with fx is equal to 2x squared minus 3x minus 7. So we're now replacing each x with x plus h. Each x is replaced with x plus h. Now, this is squared, so we get x squared plus 2xh plus h squared. Okay. Obviously, then we get minus 3 times x plus h, giving us minus 3x minus 3h, and the minus 7 comes down as well. Distribute that across, in other words, multiply it in, and there we go. Right, so now we've got fx plus h developed as far as here, okay? Now that's going in for this portion of the formula here, but we now have to do minus fx from that. So we minus fx next. All right, so here we have the fx plus h from here to here. And now we got minus the original fx, which was 2x squared minus 3x minus 7. Carry that down to the next line. Okay, and in orange you'll see I've cancelled, right? But if we just look at that before we cancel them, we would have had 2x squared minus 3x minus 7, I'll show you those cancelling now. So at this stage now, we can just have a look and see exactly where the cancelling would apply. 2x squared minus 2x squared. Minus 3x plus 3x. Plus 7 minus 7. Okay, now everything that's left gets carried down. So we see we have this coming down, this coming down, this coming down. This is what's left basically. The next line of the formula is that we're going to get as far as fx plus h minus fx divided by the h. Okay, so I'm showing that we're dividing by the h here. H, divide everything above and below by h. So we're getting 4xh divided by h leaves me with 4x. 2h squared divided by h leaves me with 2h. And finally, minus 3h divided by h leaves me with minus 3. Now, below, divide this by h and we will get 1. But we don't need that 1 there because division by 1 has no net effect on the function, okay? So this is what we carry down. Now, the last portion of the formula says the limit as h goes to 0. That means at the end, sub in h is equal to 0. So we know that this portion is exactly the same as this. So essentially what we're looking for is the limit as h goes to 0 on 4x plus 2h minus 3. Now if I let h is equal to 0 in this, I will have 4x plus 2 times 0 minus 3, which is clearly equal to 4x minus 3. And that's our answer. Okay. I'd like to remind you again that if you're asked to differentiate from first principles, you must do this method. You cannot do the quick differentiation by rule methods, okay?